I'm Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. Today I'm going to discuss about performance characteristics of an instrument. And before studying about performance characteristics of an instrument, what is meant by performance characteristics? Performance characteristics are nothing but characteristics of an instrument or performance of an instrument for the given input, how an instrument will respond and produce the output. That gives the performance characteristics of an instrument. And before discussing about that one, we will look into the block diagram of a measuring system. The measuring system mainly consists of three blocks: input unit, signal processing unit, and output unit. Coming to the input unit, in the input section, we are using a device called as transducer. What is meant by transducer? Transducer is a device which converts one form of energy into another form of energy, or we can also say that transducer can convert physical energy into an electrical energy. So, for the given input signal, the input signal is converted from physical form to electrical form with the help of transducer, and then the modified input signal is given to signal processing unit. In that signal processing unit, whatever the operations we need to perform, those operations are performed, like if you want to add two inputs, or if you want to get multiplication, or if you want to modify the signals, amplify the signals, modulation, all the operations can be performed with the help of signal processing unit. Then the finally the output will be indicated on the indicating meter. That indicating meter may be a CRO or a recorder or computer or any output unit that can be helpful to see the output waveform. So in this way the measuring system will work. In any measuring system we have three blocks: input unit, signal processing unit, and output unit. In the input unit we are applying our input, whether it is a physical energy or electrical energy. Initially, the input unit, we are applying the input signal. The input signal is initially applied to transducer. Here, transducer will convert one form of energy into another form of energy. For example, if you want to move a block, whenever we want to move a block, we need to apply a force on the block. The force we are applying on the block is a is an energy. Due to the application of that energy, the block will be moved from one point to another point. So there exists displacement. To produce the displacement, we are applying an energy or force. Due to the application of force, the block will be moved from this point to the another point. So, in this way, we can convert one form of energy into another form of energy. After that, the input is given to signal processing unit. In that signal processing unit, it will perform all modulations, amplifications, and multiplications. Whatever operations we need to perform, those operations are performed in signal processing unit, and then the input is given to output device. Here output is nothing but it is an indicating device. The device which is helpful to view the output waveform. That may be a system or CRO or meters or anything that can be helpful to produce the output. This is the block diagram of a measuring system. Next, coming to the performance characteristics. The characteristics of a measuring instrument which are helpful to know the performance of an instrument and help the measuring any quantity or parameter are known as performance characteristics. For example, if you consider any instrument, what is the performance of that instrument represents the performance characteristics. These performance characteristics include two types: static characteristics and dynamic characteristics. What is meant by static characteristics? Static. The name itself indicates that These characteristics do not vary with respect to time t. At any time instant, the characteristics are maintained as constant. Those are called as static characteristics. Coming to the dynamic characteristics, here also the name itself indicates that dynamic. With respect to time t, the characteristics of a measuring system will vary. Those characteristics are called as dynamic characteristics. Coming to the performance characteristics, coming to the static characteristics, we have different types of the static characteristics like accuracy, precision, sensitivity, resolution, and static error. These are some types of static characteristics. Now we will discuss one by one. First one is accuracy. Accuracy means it is the degree of closeness with which the reading approaches the true value of the quantity to be measured. So, as we know that whenever we need to measure any voltage or any current in the output section, if you want to voltage, if you want to measure a current or a voltage, normally we can use either multimeters, ammeters, or voltmeters. If you are want to use, if you want to measure a voltage, theoretically, the output voltage is given as 10 volts. But practically, if you obtain the output voltage as 9.99 volts, from this we can say that the practical readings are almost close to that of true value or theoretical readings. True values are nothing but theoretical calculations. Whenever the practical values are coincide with the theoretical reading or true value of the quantity to be measured, then there exists maximum accuracy. For example, the theoretical reading to measure any voltage is 10 volts, but practically you have obtained only 6 volts. So there is very large difference between theoretical and practical voltages. In this, the accuracy is very less. But whenever we want to use any instrument, that instrument should have maximum accuracy. How that accuracy will exist means whenever the practical readings are closer to the theoretical reading, then we can say that there exists maximum accuracy. Next parameter is precision. What is meant by precision? If an instrument indicates the same value repeatedly when it is used to measure the same quantity under same circumstances for any number of times, then we can say that the instrument has high precision. So, for example, if you are using an ammeter, the same ammeter is used to measure many readings. First of all, if we are using the ammeter, we are measuring the output reading. We get the output current as 10.1 milliamperes. If you use the same multi ammeter for n number of times in the same circumstances, we will get the same reading in the output section. Then we can say that the precision is high. If you are using the same instrument to measure the similar output for n number of times in the same circumstances, then there exists high precision. For example, if you are using same ammeter to measure a current, in the first instant it produces the output of 10.1 milliamperes. After 10 milliseconds, if you do the similar experiment, if you got the output of 9.2 milliamperes. Similarly, if you do the same experiment in the same environmental condition and applying the same input, if you get the output as 11.5 milliamperes. So, in each and every case, the output is different. In this type, the precision is less because if you are doing the experiment in the same circumstances, also we are not getting the same output. So, Precision can be defined as if you are doing the same experiment repeatedly for n number of times also, we will get the same output irrespective of circumstances. Then the instrument should have high precision. If you use an instrument, instrument should have high accuracy and high precision. Then if we use similar instrument, it produces the maximum output. Sensitivity. Sensitivity can be defined as the ratio of change in output to that of change in input. For a change in input that is to be measured is called as sensitivity. And change in output is generally represented with delta A out, whereas change in input can be represented as delta A in. Sensitivity is always represented with S. So, what is meant by sensitivity means if you produce any change in the input, automatically the circuit produces a change in the output. Then there exists sensitivity. For example, if you consider high pass or low pass RC circuit, in a high pass or low pass RC circuit, if you change the input corresponding to the input frequency, there is a change in the output after reaching the cutoff frequency or before that cutoff frequency. Or we can consider another example, VA characteristics of diode. If you observe the VA characteristics of a GNR diode or normal diode, if you observe the characteristics of a normal diode, when we change the input voltage, correspondingly, it produces the change in the output current. So, for every change in the input voltage, it produces the change in the output. Then we can say that there exists sensitivity. So, sensitivity is always represented with S. Next, resolution. The output of an instrument will change only when there is a specific increment of the input. Then the increment of the input is called as resolution. That means the instrument is capable of measuring the input effectively when there is a resolution of the input. If you if we observe for a particular circuit, even though if you apply the input, there is no change in the output till the input reaches to a particular value. Whenever input reaches to a certain value, or if you consider a transistor, whenever input reaches to 0.7 volts, then only the transistor will start work and it produces the output for the corresponding input section. So the specific increment in the input which produces the change in the output is called as resolution. Up to that 0.7 volts, even though if you change the input, there is no change in the output because the transistor required certain input voltage to on. Whenever the transistor is present in the on state, for the corresponding input, it produces the change in the output. That specific increment to produce the change in the output is called as resolution. Next one is reproducibility. It is the degree of closeness with which a given value may be repeatedly measured. It is specified in terms of scales of reading over a given period of time. If you are doing the same experiment n number of times repeatedly, the degree of closeness with which the values will be appeared in the output section, then there exists reproducibility. Already we have discussed about resolution. What is the main difference between resolution and reproducibility? Means in that resolution, if you do the experiment n number of times, we will get the similar output at each, we will get the similar output at each and every condition. But there is no rule that the true value of the quantity should be equal to the measured value. But in this reproducibility, If you are applying the input voltage, like for example, if you are applying the input voltage as 10 volts, and at the output section we will get the output voltage as 9.98 volts. Next, if we do the experiment, if we do the experiment n number of times also, the output reading is almost similar to that of true value, then we can say that there exists reproducibility. The output values at each and every instance are almost the same. At the same time, all the output readings are mirror to the true value of the instrument. Then we can say that there exists maximum reproducibility. So reproducibility means the degree of closeness with which a given value may be repeatedly measured. It is specified in terms of scale of reading over a given period of time. That is, if we do the experiment n number of times, also we will get the same output at the output section. At the same time, the output is equal to the true value of the quantity to be measured. Next one is threshold. What is meant by threshold? If the input, if the instrument input is increased very gradually from 0, there will be some minimum value below which no output change can be detected. This minimum value defines the threshold value of the input. So, whenever we change the input for any circuit, it produces the change in the output. In some circuit, if you change the input value, correspondingly it produces the change in the output from 0 to maximum. Whenever we obtain that condition, the change in the output from 0 to the maximum, it requires a minimum input voltage, below which we cannot identify the change in the output. That minimum voltage is called as threshold voltage. For every circuit, we need certain input. If you apply the input, it produces the change in the output. So, whenever we apply the input, then only the circuit produces the output. But there is a minimum input voltage. The minimum input voltage required to produce the change in the output is called as threshold. The voltage below that minimum voltage, if you apply also, it does not produce the change in the output. So for every circuit, it requires a minimum voltage. That minimum voltage is the voltage to generate the change in the output. That minimum voltage is called as threshold of the instrument. Next, stability. As we know that the stability means the ability of an instrument to retain its performance throughout the specified operating life. So for example, if you consider an instrument, the instrument will work for 1 day, 2 days, 1 year, 2 years, up to certain age. Every instrument having some aging effect. Due to that aging effect, the instrument cannot work properly throughout its life. So it has certain life. So the ability of an instrument to retain its characteristics through a given specified operating life is called as stability. If the stability of the instrument reduces means it cannot it cannot produce the change in the output for the changes in the input. That is, cannot operate for the given input values. So if you consider any instrument, every instrument having certain life, within that given specified life only, for the applied input, the instrument can respond and it produces the output. That particular operating period or life is called as stability. Next one is tolerance. Tolerance can be defined as the maximum allowable error in the measurement is specified in terms of some value which is called as tolerance. So if you are using any instrument, we have certain tolerance for that instrument. That tolerance may be negligible. So while we are measuring the resistance value also, there exists some 5 to 10% tolerance. So that is the maximum allowable error. For example, if you want to do any experiment and to measure the output current, the output current reading is 10.1 milliamperes and there exists a tolerance of 5%. Means there is a possibility, there is a chance of getting output voltage from 10.15 to 10.909 milliamperes. So there may be a tolerance of plus or minus 5%. That tolerance can be allowed even though the true value of the instrument is, for example, the true value of the instrument is the true value of the instrument is 10.9 milliamperes and the measured value of the instrument is obtained as 10.95 milliamperes or 10.85 milliamperes. This 0.5% is called as tolerance that can be allowed within the instrument. Due to some aging effect or due to so many reasons, there exists certain tolerance of 5%. And if you get the output within that 5%, we cannot say that this is an error. This is also a true value because there exists a tolerance of 5%. Along with this, we have some other characteristics due to which the characteristics of an instrument will changes. This that is one of error. Error is also one type of static characteristics. Mainly, the errors are occurred due to the change in the true value, that is the difference between true value to the observed value. Whenever we can identify a difference between true value and the measured value or observed value, then we can say that there exists error. Due to this error, we get some change in the output. Next, range or span. The minimum and maximum values of the quantity for which an instrument is designed to measure is called its range or span. If you are using any instrument, the instrument having certain characteristics like we have to apply the supply voltage as up to 10 volts only and the input voltage should be within the given voltage levels like that for every instrument having certain minimum and maximum values and within those ranges only we have to apply the inputs for an instrument, then only the instrument will respond to the given inputs and produces the corresponding output, and that is called as range or span of an instrument. In this lecture, mainly we focused on block diagram of a measuring system and what are the different blocks present in the measuring system. Next, performance characteristics. Again, types of performance characteristics. As we know that the block diagram of a measuring system mainly consists of transducer, signal processing unit and output unit. The transducer will convert one form of energy into another form or physical energy is converted into electrical energy and then that is given to signal processing unit. In that signal processing unit, all operations are performed and then and the output is given to the output unit. In this output unit, we have an indicating meter like CRO or signal. CRO or computer or any ammeter, voltmeter or multimeter, whatever the device which is used to produce the output on the screen, that can be used as an output unit. Next, coming to the performance characteristics. These performance characteristics are nothing but performance of an instrument and how it responds for a given input. We have two types of performance characteristics, static and dynamic. Static, the name itself indicates that it produces the output for a given change in the input without changing the time. Dynamic characteristics. The dynamic characteristics can be defined as the characteristics of an instrument that varies with respect to time t, whereas static characteristics does not varies with respect to time t. And we have discussed about some of the static characteristics like accuracy, precision, sensitivity, resolution, and static error. All these characteristics do not vary with respect to time t. So these characteristics are called as static characteristics. Thank you. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.